Hello friends, welcome to BSS Studies. I am Bala. Today I will explain new topic from chemistry, gaseous state. So in this, first we have to see what is matter. So matter means if anything occupies a certain space and have fixed mass, that is known as matter. And this matter is characterized into three: solids, liquids, gases. So in this lesson we have to talk about gases. So solids means it have definite mass and occupies space. Okay, and if I take like this a container, the molecules will arrange like this tightly. Okay, and in liquids it has certain mass and occupies space, and here in this solid it has certain shape. Okay, and in this liquids, if I take container, it occupies like this space and it takes the shape of the container. Okay, and this gas have certain mass. Okay, certain some mass and occupies space, and shape means if I take a container like this, it will occupy whole space like this. Okay, so this is the three characteristics of matter, or three parts. Actually 5 parts are there, but we have to take only 3 parts. And here in this gaseous state we have to discuss about the gas laws. Different scientists told the laws about the pressure. So these are the parameters about the pressure, volume, temperature relations. Okay, so these are the parameters, and another is the STP or NTP conditions. STP or NTP conditions. So pressure means force by area and the unit is Pascal. So here the Pascal means 1.2 mg resting on 1 centimeter square. Okay, here the pressure means force by area, and here pressure is represented by P, volume is V, temperature is T. And here pressure means force by area and the unit Pascal, and this Pascal is known as 10.2 mg. Mg means mass into gravity. This much on resting on 1 centimeter square is known as Pascal. And here if you see volume, volume means length into breadth into height. If I take cuboid, so like this, if we calculate volume, and temperature means absolute temperature means 0 degrees or 273 degrees or 273 Kelvin. Okay, and STP NTP conditions means standard temperature pressure or normal temperature pressure. Temperature is 0 degrees and pressure is 760 mm of Hg, and volume 22.4 liters in 1 mole. 1 mole of gas. Okay, so these are the parameters. And if we see first gas law, and here if you see Pascal, here Pascal means 1.2 mg is resting on 1 centimeter square, which means if I take this as 1 centimeter and 1 centimeter square, this full area 10.2 mg I am taking, and this whole 10.2 mg is rested on this particular area that is known as Pascal. Okay. And if we see first gas law, Boyle's law. What is that? Boyle's law. So what Boyle's law states means, at a temperature and number of moles are constant, at which temperature and number of moles are constant, pressure is inversely proportional to volume. Okay, pressure is inversely proportional to volume, and this, taking this proportionality constant away, we put K as a constant and take K as 1 constant. Okay, so or K like that only, take like that. So K, P is equals to K by V. So PV is equals to K. By this, if we multiply P and V, it is a some constant. Okay, and here very important, if volume is increased, pressure decreased. If volume is decreased, pressure increased. Okay, and this is the Boyle's law. And if we see some graphs, I will write statement. Statement. Statement is, at temperature, number of moles is constant, the pressure is inversely proportional to volume. So this is the statement. If we see numerically, P is inversely proportional to V, and here PV is equals to some constant. And here if we see, here we can write P1 V1 is equals to P2 V2 as the formula. Okay, so this is the Boyle's law. And if we see some graphs, graph means like this, x-axis, y-axis. So I am taking here like this, x-axis, y-axis, and if I take in this P, in this V, the graph is like this, hyperbola. Okay, sorry, parabola. And if I take like this, P 1 by V, the graph is like this. And if I take like this, pressure into volume, and here volume or P, the graph is like this. And here if I take 1 by P, here V, the graph is also like this, straight and low. Okay, and another graph, log P with logarithm values, log V, the graph is like this. Okay, without touching the y-axis. Okay, so these are the 4 graphs. And another graph is also there. And that graph is, here the pressure is inversely proportional to volume, but pressure is directly proportional to density. Very important point. Here pressure is directly proportional to density means, so pressure is directly proportional to density means pressure is directly proportional to mass by volume. So here mass is constant. So pressure is inversely proportional to volume. Okay. And here for this graph is like this. P and D both are directly means if pressure is increased, density also increase, which means straight line from the origin. Okay. So these are the graphs and this is Boyle's law. Okay. So this is the today topic. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. If you have any doubts, please comment on the comment box. Thank you.